is question 11. Here in this question 11 we have a special device like this. So we have a diameter of 1 centimeter tube like this. So and then it is bent with a 30-degree angle here, and then it goes straight, and then it is attached with a funnel like this one. And then the diameter of this funnel is equal to 50 centimeter as shown here, and the height of this one is 1.5 meter. So the question is, in this situation, so the value of y here is equal to 100 millimeter. Okay, and then we add more water in this funnel until the water level is at this level. So and then we need to calculate what is the new value of y. So the definition of y here is the distance from the surface of mercury on at the left side until the surface of the mercury at the right side here. So this is the calculation before water was added. So it is based on this diagram. So this is before the water added. So we create a few points. So here is point number 1. So this is point number 2. So and then we know the distance y is here. So and then the total distance here need to be calculated, and also the distance of this one. So to calculate this all these parameter, so we could assume that because this is the Pascal paradox line, so we could say that point 1 is equal to point 2. So we could write as P1 is equal to point 2, and P1 can be calculated as rho GB, which is the point rho GB here is the height from this level to this level. So and then we could calculate the pressure at point 2 here by using this equation. So point 2 is here, so we calculate the height of the mercury at this level. So it is given from the question that the height is 100 millimeter, so it is equivalent to 0.1 meter. So we write 0.1 meter here. So we get the pressure at point number 2 is 13,341.6 Pascal. So and then according to this one, we could calculate the height of B, because P1 is equal to P2. So we could calculate the height of B, and it is equal to 1.36 meter. And then we could calculate the height of C, which is equal to 1.26 meters. So and then when we add more water here until this level, so the pressure of water will push the mercury and it will become like this. So means that comparing with the previous diagram here, so we say that this height is y. So and then we have another height of A here, and we have another height of x here. So it is not simply, we cannot say, simply say that the distance of A here is equal to x, because at this situation, so the decrement is actually in vertical, but the increment here is in incline of 30-degree angle. So after water was added, we could calculate as this one. We assume that P3 is equal to P4. So according to this diagram, if we have a line here, so we could say that if this is point 3, so pressure at point 3 is equal to pressure at point 4. So and then we could calculate the pressure of point 3 is rho GH of this one, means that the rho GH from here with A with the value of B here, so it is equivalent to B here. So and then the height of this funnel, which is 1.5 meter. So we could write like this one. So and then we have an unknown distance, which is a, so we leave it as an unknown parameter there. So and then we could calculate the pressure at point 4 by calculating the height of the mercury of this one, and y, and also the x. So we could write like this one, and then we could simplify it as this one. And the S here means the specific gravity of the mercury. So it is equal to 13.6. So and then we have we need to do some analysis between the vertical decrement here, the vertical cylinder here, and with the inclined cylinder here. So what we could say is, so because mercury is incompressible fluid, so means the volume is remain constant. So means that the volume at this one must be equal to the volume at this inclined area. So the volume of this one is equal to A here times capital A, means the cross-sectional area times the height. And then the volume of this one, it is equal to the to make it simple, to simplify the calculation, we just imagine that we cut this area, and then we top up at this area. So means now from the inclined area like this, so if we cut it here, so and then we top up it here, so it will become a cylinder with inclined at certain angle. So if we have this one, we could calculate the volume of this inclined cylinder, which is the cross-sectional area of this one multiplied with the L here. So means now we could say that A and capital A is equal with L and A. So and then we cancel the value of cross-sectional area, so mean A is equal L. So and then the L here, the X here, okay, the X here is equal to L sine theta. So the X is equal to 0.5 A. So and then we substitute the equation. So we know that P3 is equal to P4. So we already calculate the amount of pressure for P3 and the amount of pressure of P4 as mentioned here. So and then we could calculate that A is equal 0.077 meters. So and then the new value of Y here. So it is consists of A here plus Y and plus X. So and then we could write like this one. So A plus Y plus X, and then X here is equal to 0.5 A. So we could calculate the value of Y new here is 0.216 meter.